little bit shortened the title because you've seen the title in the invitation. It was quite long. It would not fit on the slide. So I shortened it to Kubernetes Data, DR, and Mobility. So the topic is the same. Yeah, it's just a shortened title. So I'm Daniel. I'm from Portworx. So we have a software which abstracts storage within Kubernetes. It's designed for container native storage. So we are from this world, and I want to just show you what are the possibilities. But first, maybe I just shortly explain what Portworx does, because I think it's important to understand why we are doing things and then explaining what would be the benefits. So Portworx in general, it lives inside a Kubernetes cluster. So if you have Kubernetes, hopefully all of you have Kubernetes, right? Yeah. It's installed inside a Kubernetes cluster, so it's a software-defined storage layer within Kubernetes. It lives in containers, so we are fully containerized. We are also fully managed by Kubernetes YAML specs. And it's existing inside your Kubernetes cluster, and we don't care about the distribution or where your Kubernetes cluster lives. So we can do OpenShift, we can do Rancher, we can do Tanzu, we can also do self-build Kubernetes upstream something. Oh, thank you. So yeah, we're inside the Kubernetes cluster, and we offer lots of capabilities, you know, from enterprise storage for your Kubernetes cluster. So this is all about snapshotting, it's about replicating data, it's about encrypting data, and also quality of services tierings. And when it comes to multiple Portworx cluster, we can also do other fancy stuff I will show you, hopefully in a live demo. So the question is now, how does Portworx get this storage? Because data needs to store somewhere, and we cannot just do magic and store it, don't know, in the air. So basically, the basic concept of Portworx is we take local block storage attached to the Kubernetes worker nodes. So as a basic example, if you would run on bare metal, it would be just a disk, an empty disk plugged into your Kubernetes worker nodes. And we take this storage, this unused storage, not formatted, no file system on it, and we place it into a pool of storage. And so we take from all the worker nodes the storage and put it into our storage pool. And out of this pool, we serve the persistent volume claims for your pods. So if you create a persistent volume claim which is attached to a storage class, it will be provisioned out of our pool, abstracted from the underlying infrastructure. And this can happen for read-write once volumes, and also read-write many volumes. So you could have multiple pods writing data into a single volume. And the question is now, how do we achieve the goal to get local attached storage into the worker nodes? Because this heavily depends on where's your Kubernetes cluster running, right? So if your Kubernetes cluster is, for example, running in Amazon Cloud, if you use the managed Kubernetes offering from Amazon or from Google, we can also integrate in these infrastructure layers. So we have our Portworx orchestration layer, which connects into your infrastructure. And we have some integrations into several infrastructure products I will just show you. And we can now directly connect to AWS. So to provide block storage to worker nodes running in AWS, it would be an EBS volume, right? Or if you do this on Google or on Azure or even on vSphere, it would be a VMDK file. So to achieve the goal to have a block storage attached to each of the worker nodes, we can integrate into the infrastructure and provide this for you. So you don't have to manually link those block storages to the worker nodes. So this is our integration into the platforms. And then we provide enterprise storage product or storage things to this Kubernetes cluster. So meaning we have multiple storage classes for block and file. We have multiple performance layers. We have multiple protection levels also for this data. It's also about being application granular and application consistent. When it comes to snapshots, so we can do pre and post scripts for snapshots. We can also encrypt data, so we can create use a specific encryption key for each of your volumes, or you can have a single encryption key for the whole cluster. And we also can replicate data. This is something I will show later. We have multiple protection and disaster recovery features, so we can asynchronously and synchronously replicate between Kubernetes cluster running Portworx. So you can do this between an on-premise installation of OpenShift and the public cloud running in Amazon or Google. And We are topology aware, so for our protection mechanisms, we use the Kubernetes topology technologies. And yeah, we can protect or do protection and disaster recovery between, for example, cloud and on-premise. And we have a high, let's say, infrastructure agility or migration. So you can, with Portworx, you can migrate applications, so the data of applications, the volumes, and all the Kubernetes objects between multiple clouds. For example, between Google and Amazon, I will hopefully show today. But you can also migrate applications between test clusters and production clusters or back to do the troubleshooting, or even between on-premise and public clouds. You can also migrate between Kubernetes distributions, so we don't care about the distribution running there. So you can migrate data from Rancher to OpenShift to Tanzu and back, whatever you want. And you can also migrate the data between managed Kubernetes offerings like Amazon, Google, Microsoft, and self-hosted Kubernetes offerings. So in my demo today, I want to show how to migrate an application running on Google Cloud, so GKE, to EKS, so to Amazon managed Kubernetes. High level, how do we do this synchronous disaster recovery, asynchronous disaster recovery? You have a source cluster. In this source cluster, we installed Portworx, and we have applications running. So each application has a persistent volume claim, which is a Portworx volume then, and is stored in the Portworx layer with all this abstraction I explained. And we need a second cluster where we want to replicate to. And we establish a pairing between those clusters on the Portworx level and also on the Kubernetes management plane level, which asynchronously replicates the data between the Portworx clusters and also the objects, the Kubernetes objects between the Kubernetes clusters. And this is done by a time schedule. So this means the asynchronous disaster recovery we do. So in the cluster 2 here in this example, we would have a copy of all the volumes from cluster 1. And we would also have all the Kubernetes objects in cluster 2, but they will be scaled down to 0. You can select what you want, but by default, it's scaled down to 0. So in cluster 2, we have volumes, we have Kubernetes objects. And in case of a disaster, so cluster 1 crashes, goes away, you switch it off. You have a single command you need to type on cluster 2 to get all the applications back. So it's just one command, and all the applications will be scaled to the level they know from the former cluster 1. And this means the applications are now then running there. So if you look into the technical details, we create a so-called cluster pair spec. And as I mentioned, we are managed on Kubernetes layer. So we have YAML specs for everything. So you create a cluster pair spec. And this defines the pairing of the Portworx clusters and the Kubernetes control planes. This is created at the destination cluster, and you copy it to the source cluster and apply it there. So the source cluster now knows what's the destination for this cluster pair. We need an object store to synchronize the volumes we transfer from one cluster to another cluster. We create a schedule policy, which just basically describes how often something should happen. It can be minutely, it can be hourly, it can be daily, weekly, or you can define just do it every minute or 5 seconds. So you define just when to trigger an event. And you define the interval, or if you want to do it daily, weekly, monthly. And then we create a migration schedule spec. And this migration schedule spec defines what to migrate. So here you can have selectors, or you can say you want to have volumes, or you only want to have the resources, or both. And this is namespace, so it's based on a namespace. You replicate a namespace from cluster A to B, and you reference the schedule policy. So how often should this happen? So now I will try to demo it. So I need to move the screen. So you should see. Yeah, you might see. I cannot see that clear. At the Google Cloud Engine, so can you see it there? Yeah, there's one cluster in the Google Cloud Engine, Kubernetes engine, and there's one cluster on the AWS cloud. So seem to be a little bit small. But yeah, it's the two clusters which are pre-created. And I also will move my command line to the screen, because that's the more interesting thing. So let me quickly, where am I? So it's not typing. I also recorded a video, so in case this fails, I can show you the video. But let's just retry and close the presentation screen. Maybe this mixed up something. No, it won't. That's funny. Let me just try to mirror my screen. Let's see. So, if you ever work with Windows subsystem for Linux, don't do. Let's try again. Now something's starting. So you see me typing? Yeah. So I will just connect to my GKE cluster. I'm there. And I will also connect to my Amazon cluster. And I'm there. And as you see, it's quite exciting typing in front of people because everyone waits to just do an error. So I pre-created the scripts which will run. I don't know if you know this script where you can just pre-create all the commands and then they will be executed. Great stuff. It's called demo magic, so you can find it in GitHub. So I will just start the demo magic, preventing me on doing typos in the live demo. So this one is now just running commands I pre-created, but they are running live on the cluster. So just to show, this is the Amazon cluster in the upper half. I will just show the nodes. So it's running on Amazon. And this one will receive all the data, so I will just do a kubectl get all with a watch, so it will just refresh every 2 seconds and see if something's coming into the default namespace. So now I will go to the Google stuff and do the same on the Google Compute Engine. So it shows the nodes. It's running on Google. And I will show you this cluster pair YAML spec, which we create to pair those clusters. So it's here. So it defines the namespace where it's running. It defines the clusters. It defines users. It defines the target IP address of the target cluster. So this one is here now pointing into the Amazon cluster. We'll go out and just apply it. Now we created this cluster pair. That's a custom resource definition we created. And let's just have a look on it. So I now see my remote cluster. You can define multiple remote clusters, so you can replicate 2 different clusters. And now let's have a look to the cluster pair object itself. So this looks good. So we successfully paired the storage layer, and we successfully paired the schedulers. So now the connection should be there. Clear the screen. I will show you my application. I don't know if you know Pet Clinic. That's a demo application running on Spring Boot. It uses a MySQL database. So here it's running in the Google cluster. It's up, so the deployment is ready. The MySQL deployment is also ready. The services are up and running. And if I check the ingress, I see the IP address of the ingress, which is created by the Google Cloud. So hopefully when accessing this one, it should be there. Yeah, it is. It's always good to have cat pictures. So that's just a sample database application. So let me just add myself as a new owner. And add a new pet. Oh, it's Birdie. It's pre-filled, yeah. But it's a hamster. Poor hamster. So now if you just scroll the owners, so I'm there. So now we see the application is there. I define the schedule policy, so how often should the replication happen? This is now within every minute. And I also define the migration schedule I was talking about. So the migration schedule defines what to migrate. So this is here, this lives in the kube system namespace. It refers to the remote cluster 1 cluster pair, and it just replicates the namespace default, and it doesn't start the application on the destination cluster. You could select that you want to start it, but usually in a DR construct you would not do this. And this also refers to the DR policy, so to the timing. Let's get out of this. You just apply it, and now it's created. It's a Kubernetes object. You can have a look to the app migration schedule, which was just created. And now you can also use our stork cuttle. So we use a component called stork, the storage operator for Kubernetes. This is the one who influences the scheduling decisions when running a Portworx cluster. But this is also doing all the data copy operations between the Kubernetes clusters. And here we can see there is an application migration started. So here we can see now. That's a very small resolution. So you can see it's running. So it's a cluster pair remote cluster 1. It's in progress. So it's copying. It should start copying data. So it's 44 seconds old. This can take some time for the first start. But hopefully this will start soon. So it will first copy the volume from the source to the destination. And then it will copy the Kubernetes objects from the source to the destination. And this is the point where you then should see in the upper half of the screen that all these objects appear now in the Amazon cluster. So let's just give it some more seconds. I haven't tested this prior to this session because Google took a long time today to create the Kubernetes cluster. But hopefully it will start soon. If not, we can do a troubleshooting after the session. So I'll say I give 2.5 minutes, and if not, I need to later to troubleshoot it, what happened, and show you the rest in the video. So it seems the event happens, which should not happen in live demos. It does not work, as it did on the tests. I will let it wait in the background and just show you what I pre-recorded without networking errors and stuff like this. So can you see? Yeah, you should see it. So this is all the commands I run. And we're currently waiting here. Let's just jump into this. Yeah, we're currently running here. So it's all this, okay, it's all this stuff now coming. It already migrated at this point. Let me just scroll back. Yeah, so this is the point where we currently stuck. So this is the schedule policy, the migration schedule, which was created. And we apply this one, and then we see this on the destination cluster as soon as it's deployed. Sorry for this, but it's live. So, yeah, seeing the migration schedule, as I already showed, and seeing also the migrations. So this is the point where we're currently stuck. Maybe I'll check the screen later. Maybe it just replicated it. But usually, you should see transferred data. So here you see the bytes transferred, and you see here now application. So it just synchronized the volumes, then it synchronized the applications, and they will appear in the destination cluster. So now the objects are here. But the important point is, let me just pause this one. The important point is these deployments here are scaled to 0. So the objects are there, but they are not running in the destination cluster because we don't want to have them running yet because the source cluster is still alive. So now in this video, I just paused the migration. I did not kill the cluster. So migration processes are paused to simulate the cluster failure. And as soon as the last sync was successful, I will switch to the destination cluster and just spin up the application itself. So this should happen there. Yeah. So this is one command. It's store cuttle activate migrations, which brings up all the applications back in the destination cluster to the scale we've had in the source cluster. And here to show that it works, I show the ingress in the Amazon cluster, and I did not manage to have a quick ingress running in Amazon, so I just patched the service type for the pet clinic application to load balancer because this is easily done in Amazon. So if you know how to create quickly an ingress in Amazon Cloud, let me know. So this now scales up the pods. As you see, the MySQL is already there. The other application, it's a Spring application, so it takes some time. And when it's there, you can just jump forward. It will be also visible in the browser screen running in Amazon. So somewhere in the end of the video, it will just be there. Yeah, so there it is. So it would then run in the Amazon cloud. Let's just quickly check. No, this is not working. Something's broken. So, yeah, this was a kind of live demo and presentation. So, any questions on this?
Oh,
yeah.
Oh, great. All right, well, let's give a round of applause then. Thank you. It wouldn't be a talk without some technical difficulties, so we'll come over a bit further over so the camera can get us. All right, so we do have a few questions already. So here we go, they're up on the screen if you want to have a look. How do you handle node affinity when then nodes of the cluster run in different zones?
Yeah, so we are aware of Kubernetes topology. So we use rack, we use zones, we use regions. When creating a volume, you can define a rack affinity. So if you create a volume, you can define in the storage, so you can define on the storage class layer in which rack this volume should be placed. If you also have zones defined in Kubernetes, availability zones, we by default take care that a replica of a volume is placed in different zones, but in the same region. This is the default behavior. So hopefully this answers the question.
Christian? Yep.
Yep.
Good.
Okay.
Yep. All right, nice. Thank you for the question. All right, next. Does the data get stored somewhere between the source and the target cluster?
Yes. So the volumes or the data is stored in an S3 bucket. I showed this also in the presentation. So we use a S3 bucket to store the configure, so the objects and the volumes in this bucket. So it's transferred into this bucket and taken out of this bucket at the destination.
Thank you. Sorry, I have to laugh at this one. It says it's from asking for a manager. Is there a UI to see synchronization status?
We have a UI, yes, but I'm not sure if it will show synchronization status. It will show if you have multiple Portworx clusters. So each Portworx cluster lives by itself. And we have a UI to just collect all the information from all the Kubernetes clusters. But to be honest, I'm not sure if it also shows replication status. It just shows the health of those clusters. So I need to check if we all. But if you have a manager who's interested in this and wants to buy a amount of Portworx licenses, we might integrate it.
Can we provision this volume data streamer on premise?
Yeah.
If not, how do you dodge GDPR impairments?
Yeah.
But you said yes already, so I guess I don't
Yeah.
need to
So
read the if not
Portworx, Portworx itself. You can install it on premise. So if the question is, if Portworx runs on premise, for sure, yeah, we just need a Kubernetes cluster and block storage. And also the S3 bucket we need to, we replicate the data into it must be S3 compliant, let's say it this way. It doesn't need to be Amazon S3, it must be an object store compatible to S3.
How do you configure migration features between two clusters?
So this, I think, was already answered in the...
Sorry.
Or is there a more specific question? Maybe I did not get this. So it's the cluster pair
definition. Does anyone want to out
definition.
themselves as the question asker? No one
Maybe the
wants
question was asked before I showed
right.
how this works, yeah.
Is the PV replication relying on snapshots, and can these be incremental?
So the PV replication, which Portworx does inside the Portworx layer, it's technically also using snapshots, but you don't get in touch with this. So the PV replication, or the replica set you define, or the replicas you define for Portworx volume, means you need this volume on one or two or three worker nodes in the cluster. And this data is replicated during the write. So if your application writes the data into its volume, it's replicated to the replicas you defined. If you define a replica set of 3, then it will be replicated into 2 other volumes.
Okay.
So this is not done by snapshot. If we need to resync this stuff, we also use snapshots just to get the data managed, but you don't get in touch with this.
So this is an interesting question. Does the replication only work in one direction, or are you able to have up and running systems on several clusters with bidirectional synchronization?
Well, it's not really bidirectional, so it works in different directions. You just need to define other cluster pairs. But you should not try to replicate an application to the other cluster and replicate it back, because it makes no sense. But you can define multiple cluster pairs. But one cluster pair is always source to destination. But you can switch back, so you can also say the cluster 2 is now the source for another application, replicating it back to the cluster 1.
Do you still require proprietary kernel modules on each node?
Yes, we do.
Okay, that was easy. Can you tell us some replication performance limits, I guess?
Yeah, replication performance depends on the underlying. So it depends which kind of replication you do. If you do async replication, we basically don't care about performance, so network performance, but if you define a schedule of 1 minute, you should be able to replicate change data within this minute from cluster A to B. If not, it will just pause the next schedules and finish the first one. So you need to have the bandwidth to fulfill this, but this is just simple math. If you do a synchronous replication between your clusters, which is also possible, you need a latency of maximum 10 milliseconds. 10 milliseconds between the clusters. So this is just designed for metro environments. So you should not try this from on-premise to public cloud, because you will not. So the latency will kill you.
All right, and on that happy note, thank you so much, Daniel, and thank you to everyone for attending. Of course, we do now have our after party out in the piazza, so please feel free to go out, enjoy the barbecues. We've got some cocktails, got some beer, non-alcoholic beverages for those of us who are into the non-alcoholic drinks right now. And yeah, other than that, please give Daniel a big round of applause. Thank you so much, Daniel.
Thank you.